All right, Zayed, are we all right? My videographer?
Yeah.
Okay. How's my tie look? All right? Do I look good? Yes? Do I look good? I make this look good, don't I? Yeah. Windsor knot. I helped Zayed learn how to do a Windsor knot. Okay. It's the beginning. The beginning of greatness is learning how to do the Windsor knot. Okay. We're going to learn about electronegativity today. I'm going to go over this. After chapters on electrons, chapter 5, atomic structure, chapter 4, ionization energies, intros to bonding that we've done. Electronegativity should be pretty easy. Anybody give me a definition of electronegativity? Even if it might be from the book, try to put it in your own words. Baslin.
It's the ability of an atom to attract electrons.
All right, the ability of an atom to attract electrons. All right, I don't mind that. But may I speak freely, and that's not incorrect, just incomplete. Okay? So we want to add to it. See, don't feel burdened that you have to give the entire answer. Clear? I will not, do something weird like, make fun of you or, well, I may do that, but, I'm kidding. No, I won't. I want you to try. Come up with an incomplete answer is better than coming up with the answer. Don't feel, it'd be too much pressure to come up with the entire answer, wouldn't it? Isn't that a little, yeah? Yes, Basil, would you like to take a second shot at it?
While in a compound.
All right, so you want to put it all together. The ability of an atom to attract electrons while in a compound. All right, what are you trying to say, Basil? That's actually correct. Everything you said is correct. However, you're being a little vague. But it's correct. Yeah, it's correct. If something's in a compound, if an atom's in a compound, what is it going to have? Starts with a B. It's going to have what? Bonds. James Bond. Yeah, it's going to be bonds. Yeah, there's going to be bonds there, right? James Bond. James Bond. Yeah, there's going to be bonds there, correct? So it's an atom's ability to attract what kind of electrons? What kind of electrons? Just every ordinary electron? Electronegativity is the ability of an atom to attract, starts with a B, bonded electrons. So, in order to evaluate electronegativity, you want to see an atom in a compound, right? Molecule or a formula unit. A molecule is the result of what kind of bonding? Do you remember from last year? You did this in biology. What is it? Covalent bonding. Yeah, that's a molecule. A molecule is a particle, a single entity with identity. Carbon dioxide is a particle, correct? One carbon dioxide molecule that has covalent bonding. What is a single entity, single particle that has ionic bonding called? Anybody know? You may not know this. How many people call like a sodium chloride molecule? How many people have said that? Right or wrong? I'm not saying you're wrong. I'm not saying you're terrible. Anybody say that? How many people have never said anything because they're not sure what it is? Just say carbon dioxide particle, they'll say, yeah? A little better, yeah? Yeah. Kennedy, you shaking your head. Yeah. Well, you know what it's called? You know what a particle of sodium chloride is called? Anybody? Starts with an F. No, not that word. Yeah. What word is it called? It's called a formula unit. I know. You'd think they'd come up with something that sounds a little bit better than that, right? A formula unit. But that's what it is. One formula unit. Okay. So the way you evaluate, what are you laughing at? The way you evaluate, you can say what you want about Zayed, but he has a great smile, okay? It's like his whole body is smiling,
Stop.
It stopped? Did it stop?
No, stop.
I should stop?
Yeah.
Okay.
I'm gonna blush.
He's blushing. Yeah, Tough for an Arab to blush. I mean, he's very dark. Exactly. Yeah. A prince of the desert, Zayed. He's very dark Arab. He's a wonderful person. Okay. I'm embarrassing him. Of course, you say Zayed in an Arab country and the whole class stands up. A lot of Zayeds around. Okay, but there's only one Zayed in this class. Excellent. So, what causes electronegativity? It says an atom's ability to attract electrons. Anybody else? Who came up with the concept of electronegativity? Anybody? Was it Kennedy? Kennedy, did you come up with the idea? You did. Excellent. I like that. You would never have known that knowing Kennedy. And who assisted Kennedy? Anybody particular? Linus Pauling, yeah. But what was Linus Pauling was actually most famous for two things. What two things? Anybody idea? Anybody figure it out? No?
He did work on the structure of DNA.
Okay. Did he really?
Yeah.
Is that what that says? Read that sentence to me.
In 1954,
In 1954, Linus Pauling,
was given the Nobel Peace Prize.
he won the Nobel Peace Prize.
That he won the Nobel Prize in chemistry
He won the Nobel Prize in Chemistry
for work that he did on the DNA, on the structure of DNA.
for work he did on the structure of DNA. Does it say that? I know he did work on chemical reactions. What else was he known for? He didn't have any well, I wasn't in his laboratory, but he had very little data to support these really wild claims that ended up to be possibly true. We're still debating it to this day. The efficacy of what? The efficacy of what? The effectiveness of what? Vitamin C. Taking vitamin C in massive doses helps to ward off diseases. Did you read that? Anybody? Miguel? No? You're looking up Linus Pauling. Alex, did you read that? No? Look up vitamin C and Linus Pauling. It's quite amazing, really. What else was like? I feel like I'm a dentist pulling teeth. This is 8:30 in the morning here in the great country of the UAE, and people are like half asleep. How many people want to be here? Raise your hand. One person. Where are you from? No, Armindo, where are you from? Where? Angola. I like that. Are you representative of people from Angola who love quality education at 8:30 in the morning? It's pretty amazing. Excellent, I like that. He's from Angola. Okay. Anybody from Europe want to be here? No? Any Americans want to be here? Jordanians? All right, Basil, we got a maybe from the Jordan team. We have no yeses from the American or the European contingent. How about Koreans? Any Koreans want to be here? No Koreans. So we just got a definite yes from the only Angolan in the class. I like that. I like that. Okay. No Canadians? The good witches of the North? The Glindas of the North American continent? The people who put the Americans to shame? No? No? All right, I'm a little surprised at that. I expect more from our Canadian team. Excellent. Venezuelan team, do they want to be here? No? No from Venezuela. Excuse me? Who? She's not. She's from Brazil. What's wrong with my brain today? The Brazilians, do they want to be here? Yes or no? No? The Brazilians don't want to be here. Okay. All right. Very good. Excellent. So we have one person who wants to be here, and he's from Angola. Go figure, right? Excellent country. Wonderful. They speak Portuguese. Okay. Now, you speak Portuguese? Excellent. Okay. Now, so let's look and see what element would have the highest electronegativity and why? What element would have the greatest attraction of bonded electrons and why? What element would have the greatest attraction for bonded electrons, and why?
Hydrogen
Hydrogen?
has only one. Oh, sorry. No, no fluoride.
Yeah, fluorine has the highest electronegativity. That's assigned a number of 4. No other has a number of 4. And why is that? Why is that so? Why is that so? Why does it attract bonded electrons so dramatically? Any ideas? Based on what you know of atomic structure, what do you think? Anyone? Shall we save that to go, and we'll go to the board, and maybe when we make our second video, maybe I'll explain that a little bit. You should have a pretty good understanding as to why, based on your experience with atomic structure. Okay. Now, the electronegativity decreases where the lowest electronegativity would be here. Francium, this corner. This would have the lowest electronegativity. This would have the highest electronegativity, right? Now, what did we say about ionization energies? Which has a very high ionization energy? Not the noble gases. We're not talking about the noble gases. We don't talk about electronegativity of noble gases. Why? Armindo. They don't react. They don't form molecules. They don't do it. Well, yeah, that's the heavier ones might, like xenon difluoride, xenon tetrafluoride maybe, but by and large, noble gases don't form bonds, so, and plus, these definitely don't. They might as they get heavier, but generally not. So we don't have to worry about their electronegativity. So let me ask you this. If you can't figure out why fluorine has the highest attraction, why does francium have almost no attraction for bonded electrons? Why? Francium. Francium, cesium. Why would they have the lowest electronegativity? Why would those elements have the lowest tendency to attract bonded or shared electrons? Well, first of all, they want to do what to that one electron it has? They want to do what? They want to get rid of it. Remember, we looked at ionization energies. It's very loosely held. It's easily, those elements are easily ionized. Remember, look at your graph. Very low ionization energies, aren't they? Group 1, aren't they the lowest ionization energies? Right? They're the lowest. They're going to hold their electrons loosely. Not only do they want to get rid of their one valence electron, but they don't care if they are attracted to other electrons. They want to get rid of it. What francium is generally what kind of particle does francium form? What kind of chemicals? What kind of compounds does francium form? It starts with an I. Transfer of electrons. No? I, the I word. You had a little bit of this in biology. What kind of compounds does francium generally form? Ionic. And ionic bonding is when you do what to an electron? It gives it up, right? It transfers it, doesn't it? So there's no real electronegativity there that matters, is there? Because it just gives it up. Like sodium chloride. Does chlorine have a high tendency to attract bonded electrons? Chlorine, yes or no? Look where it is. Does it have a high tendency? Yeah, chlorine is a 3. Pretty close to 4, isn't it? Whereas francium is like 0.65, 0.7. Chlorine is like is 3. So chlorine takes it, and what atom does the chlorine ion have when it gets that electron? When the chloride ion, what's the valence shell of the chloride ion? What's the valence shell of the chloride ion? 3, that's right. That's right. And how many electrons does the chloride ion have in the valence shell? Before it bonded, it had how many? It had, in the valence shell, it had how many?
7.
It had 7. How many does it have now?
8.
It has 8. And how many total electrons does chlorine have? Armindo, you're about to say it. No, after it bonds, after it becomes a chloride. See, before it bonds, it's called chlorine. After it bonds, it's called chloride, right? So how many electrons does the chloride have after bonding total? 18, right? No. Listen to my words. Listen to my words. Okay? How many total electrons does chloride have? Remember, it's chlorine has 17 electrons. It gains 1. Simple math. 17 plus 1 equals 18. So let me ask you again now. How many total electrons does chloride have? 18. How many valence electrons does chloride have? 8. You see the difference? Yes or no? Yes? Okay, good. Now, excellent. What noble gas has the exact same valence structure as the chloride ion? Argon. You get it? Let's say it bonded with sodium, gave up its electrons. How many total electrons does sodium have after bonding? How many total electrons does the sodium ion have? 10. Good. How many total electrons in the valence shell of the sodium ion? 8. What is the noble gas with the same valence structure as the sodium ion? Neon. Do you understand? Those are excellent questions on a quiz or a test, correct? Yes or no? Pretty
Yeah.
cool? Yes? Okay. Let's stop this and we're going to go to the board. But do you get it? Clear? Yes?
Yeah.
Okay, let's go to the board. And what I'm going to do is I'm going to draw a periodic table on the board, blank one, and we'll look at it, okay?